Okay, we're working on the Chapter 5 practice test. Remember what I said, if you ever approach a problem and don't know where to begin, factor. That's almost always the first step. So this one says state the domain. So what should go through your head is, she wants me to tell her what values x can be. Well, when we have a fraction, the only thing that can't happen is the denominator can never equal 0. That's undefined. So that immediately tells me, oh, okay, I need to set the denominator equal to 0. I'm going to put my 1 in, so I have that coefficient. And I'm going to find out what values make it 0. And then I'm going to exclude those values and use my interval notation, because it does say interval notation, so that's something you want to have highlighted. And then I'm going to use my interval notation to write my answer showing that everything works but whatever makes this 0. Because that's the only thing that can't happen is for the denominator to be 0. So I'm looking for factors of 12 that subtract a 1. It's a double bubble. The last sign's negative, which means the signs will be different. So this says they'll be different. So that's the only way to get negative 12 is one positive and one negative. And the next sign says make sure you make the largest number positive. So the large number must be positive. So factors of 12 that subtract a 1 are 4 and 3. Make the large number positive. And remember what I said, so many errors on the Chapter 4 test could have been found if students just stopped right here and checked. Is 4 minus 3 positive 1? Yes, so I got my signs right. And then we learned if A times B equals 0, either A is 0 or B is 0. So by solving these, I'll find my two excluded values. Then I can graph it and then go to my interval notation. So subtract 4, subtract 4. So x cannot equal negative 4, because if I put negative 4 in, 16 minus 4 is 12, 12 minus 12, I get 0 in the denominator. So I know negative 4 is going to be my first restricted value. So I put a big circle there to show negative 4 cannot be one of the values for x. Then I solve this one for x, and I find my other restricted value is 3. So if I put 4 in or 3 in, that makes the denominator 0. 9 plus 3 is 12 minus 12. Yep, makes it 0. So then we learned every other number in the whole world works. Anything between them, anything to the left of negative 4, anything to the right of 3. So now I need to follow that order. It's kind of helpful if you put your negative and positive infinity in. So I need to follow that order and write my domain. So starting on the left, negative infinity, and remember we use all parentheses because we have to show negative 4 is not included. United with this interval is negative 4 to 3. United with this interval is 3 to infinity. All parentheses because we cannot use those two values. They're excluded because they make the denominator 0. So that's the answer that we are looking for, because it said write your answer in interval notation. Okay, one down. Next we have simplify. And like I said, if you're sitting here going, what do I do? Factor. This one you'll want to factor numerator and denominator. When we do domain, we only care what makes the denominator 0. So notice I didn't even look at the numerator. It could be an elephant head up there. I don't care. So it doesn't matter. It's the denominator that can't be 0. But when we're simplifying, we need to factor both. So hopefully you see that this is a difference of squares. A difference of squares is always one of each. So x plus 2, x minus 2. So we take the square roots and we add them. Then we take the square roots and we subtract them. What you should notice about this one is it's written backwards. So I need to put it in the correct order. So it's a negative x and a positive 2. So we learned when your leading coefficient's negative, you take out a negative 1, divide each of these by negative 1, and then write what's left in parentheses, positive x minus 2. And remember what I said, do not lose that negative. It's part of the answer. It's my GCF. It has to stay with the problem. So we took it out because my leading coefficient was negative. Now notice it's a positive, and I go ding, ding, ding. There's 1. So what's my answer? X plus 2 over negative 1. But we learned you really don't want to leave a negative in the denominator, so we learned we could move it up, but because there's 2 things there, we will have to put them in parentheses. So you could write that for an answer, or you could write, distribute your negative 1, negative x, negative 2. So either of those would be considered correct. Or you could have at this point done division, monomial division, x divided by negative 1, negative x, 2 divided by negative 1, negative 2. So most of the time I think they leave it like that. I don't know. You'll just have to read the directions, what they want on the test. And you'll probably notice that some of these are a little squashed, so you may want to use a separate sheet of paper for some of these. It depends how big you write. So I think I'll probably use a separate sheet of paper for E and G, just because I know how much work they take right now. But just FYI, you probably don't want to try and squish it all into this. Okay, so that is 5.1. This is 5.1. Then 5.2 was our multiplication and division. Same exact steps as this. Factor everything, cancel common factors, write what's left. So we have difference of squares. Remember how I said they are all over the place in this chapter. We had 1 here. We have 1 here. We have 1 here. They're everywhere. So be on the lookout for a difference of squares. Oh, and another one there. Look at that. 4 difference of squares and 4 problems. So very common factoring pattern. So with multiplication, we just factor like maniacs. So we have difference of squares, x plus 5, x minus 5, because remember, we can never cancel things that are added and subtracted, but once we turn them into multiplication, then we can cancel, just like regular fractions. Here we have a double bubble, and the last sign's negative, so that means there'll be 1 of each, so that tells me they'll be different. And this tells me make the larger number negative. So factors of 10 that subtract a 3 would be 5 and 2. Different signs, larger number negative. So then pause right there, 10 seconds. Negative 5 plus 2, does that give you this number? Yes, so that's how you can check your signs. So 5 goes with the negative, and 2 goes with the positive. And then it's times. I see no exponents here. So when there's no exponents, that means only a GCF. I don't see a GCF, so those 2 don't factor. They just stay the same. So look at your problem. Is it all multiplication now? Yes, it is. That gives me permission. See how there's no addition or subtraction outside parentheses? That gives me permission. Anything divided by itself, 1. Anything divided by itself, 1. And we learned in this section the only thing that matters is 1 has to be in the numerator, 1 in the denominator. So they can be in the same fraction or they can be kitty-cornered like this. As long as it's multiplication, we can do that. But if it was addition or subtraction, no way. We could not cancel. But since it's multiplication, we can. So that's looking like x plus 5 over x. And remember, we cannot cancel here because this is added. Never cancel things that are added or subtracted. Only things that are multiplied like they are here. It's not so bad, huh? As long as you learned your factoring in the last chapter, you'll be just fine. Okay, so division. Who remembers the little acronym for division? Keep, change, flip. So we don't do that with multiplication. We just multiply, keep everything where it's at. With division, we have to flip the second one. So students get really involved in the factoring and they forget to flip it. So put those arrows there. That's just a good, safe thing to do. So for B, we have 2 terms. So we're supposed to go down the list. GCF, squares, cubes. Is there a GCF? Yes. So if there's a GCF, you always do that first. So y is common. So take a y out of each term, and we're left with y plus 1. No GCF. Next thing we check is squares. Yep, difference of squares. So remember, the minus says add the square roots, then subtract the square roots. So y plus 2, y minus 2. Change to multiplication, flip. So let's go ahead and do the top one first down in the denominator. So this is another difference of squares because 2 terms, GCF first, no GCF. Squares, yep. So add the square roots and subtract the square roots. Oh, gee, wow, why did I write 3? That was weird, wasn't it? Okay, so denominators factored. Now we have to do this. So factors of 6 that add to 5, 2 and 3, all plus signs. So that means they're both plus. And you can see 2 plus 3 is 5. Okay, this is the fun part. Now we need to cancel like maniacs. So we have y plus 2 divided by y plus 2, 1. Y plus 1 divided by y plus 1, 1. Anything else? Doesn't look like it. So that means my final answer is going to be y times y plus 3 in the numerator. And remember, we don't multiply it out. We leave it in factored form. That's what this is called. Over, whoops, off the page, Norris. Y minus 2 and y minus 1. And there's no further canceling because, yes, there's a y, but these things are subtracted, so you can't cancel it. So that would be your answer. And I don't think we have time to do another one, so I'm going to stop the video and start it on the next problem.